good day and welcome back to our science physics class. Today, we will learn about one of the fundamental principles of science, and that is the second law of motion. Before we go to that, let me ask you a question. Have you ever tried to help your parents going to a grocery store and buy goods? Have you ever tried pushing a cart using your two hands, just like this? So easy, right? Now, have you also tried pushing a cart using your index finger alone? Like this one. What does it feel like? Anyone? It's harder. Who would do that? Pushing a cart with loads using only your index finger. Of course, you would do things that make your life easier. And that is explained in physics. Specifically, the second law of motion. What this law tells us? It tells us that force is directly proportional to mass and acceleration. Oops, don't be overwhelmed. When we say F here as a symbol, it's the force, which has a unit of measurement, kilogram, meter per second squared. Whereas M stands for the mass, and it has a unit, kilogram. And lastly, the A, that is the acceleration. Acceleration has a unit of measurement, meter per second squared. We all know all symbols here, but what is force? What is mass? And what is acceleration? To start with, let me ask anyone from the class who knows about force. Please raise your hand if you want to share your ideas. Yes, Dana. Very good. When we talk about force, it talks about how you pull or push an object or any other interaction on an object that makes it accelerate or decelerate. Did you get that? Now, what about the mass? What is mass for you? Based on your experiences before, in your previous class. Anyone? Yes, Princess. That's right. When we talked about mass, it's the amount of matter in an object. How would you know the mass of an object? We will use, ta-da, a digital balance. Digital balance can help us identify the amount of matter in an object, just like this one. I'm holding a dynamic card. Let's try to figure out the mass of this dynamic card here. So, let's just put this one on top of the digital balance, and as you can see, it's about 500 grams. Remember, in the Newton's second law of motion, we are going to use kilograms. So this is 500 grams. We will convert it to kilogram. And that is 500 divided by 1,000, resulting to 0.5 kilogram. Okay? What about acceleration? Acceleration is about how quick an object's velocity change over a period of time. Okay? So, let's figure out what does it mean to say when we say second law of motion. Let's do some testing here. I have prepared this 500-gram dynamic card, tied it to a string, and on the end of the string, I tied a 100-gram load. Or I prepared here different weights. I will place the load on the edge of the table. I don't know if you can see it. Let's move here. forward, and at the count of 3, I will push this one down, and let's try to find out the acceleration on this object, the dynamic card. Are you ready? 3, 2, 1, and drop. So, if you are going to check on the time it takes for it to go down here, and if you observe acceleration on this card is faster. Okay? It's a bit faster. Let's compare it to the cart with loads or weights. I have here 200 grams of weights. I'll put it on top of the dynamic cart. Plus 100 grams of weights or load. And then a 50 gram. To add it all, we have 350 grams of weights. Okay? On top of the dynamic cart. Let's try to figure out what could be the effect on the acceleration on this object when we added weights. Okay, so this one we have 500 gram dynamic cart plus 350. This is a total of 850 load. Okay, and considering that we have the same load here that we will push on the end. Okay, so same load as the first try, but different mass here. Let's try to see. Ready? 3, 2, 1, drop. Have you observed the difference? Yes. Anyone who can state the difference? Yes, Elmi. That's right. It states here, or in our experiment, it shows us that acceleration can be affected by mass. It just shows us the relationship between acceleration and then the force. What does it mean to say? The higher the force you put, the higher the acceleration. When we say when one goes up and the other goes up, that is called direct relationship. Meanwhile, we have also observed that when we change the mass here, acceleration lowers. So it means that acceleration has inversely proportional relationship with mass, or indirect. I would just write here inverse relationship. With what? Let me complete this. Acceleration has direct relationship with force, and acceleration has inverse relationship with mass. Direct relationship means when one goes up, the other will go up. And vice versa. When acceleration goes down, force will also go down. Or force, when force goes up, acceleration will also go up. When force goes down, acceleration will also go down. In the inverse relationship, it's the opposite one. Acceleration, when acceleration goes up, mass is down. But of course, we are checking on the objects first. So if the object is heavy, the heavier the object or higher the mass is, what will happen to the acceleration? It's slower. Okay? That is inverse relationship. I hope you have learned something from me today. So again, our lesson for today is about Newton's second law of motion. Okay? That states that acceleration is directly proportional to force and inversely proportional to mass. That's it, everyone. Thank you for listening. Bye! This is Teacher Irene again.